We're going to look at a situation now where our vessel is in dock and the water density lies between fresh and salt water. In previous examples we were just simply in freshwater or salt water, but now the density of the dock water is going to be between those two values. So how do we solve the problem? Well, we must initially find our underwater volume, and the most important principle here that you must understand is that with all freshwater values, for example, if you were at 6.8 metres draft in port, your underwater volume would be the freshwater value, 13,771. Whatever draft you're at, that is the underwater volume, the freshwater value, because freshwater density is 1. And we know that density is weight over volume or mass over volume. Therefore, if our density is 1, the weight and the volume must be the same value. They've got to be. So at a draft of 6.8 metres, in freshwater our underwater volume is 13,771, and also our weight is 13,771. And it follows that if we were in salt water at a draft of 6.8, then our weight must be more because the water is more dense, therefore it takes more weight to sink down to the 6.8. Now if you multiplied 13,771 by 1.025, which is the density of salt water, you will get a displacement of 14,115. So, in the tables, freshwater value equals underwater volume. We know weight is volume times density, so if density is 1, the weight and the underwater volume are one and the same thing. And looking at the formula, density, mass over underwater volume, 1, these two values must be the same. Okay? So that's the important principle before we look at a problem that you need to understand. So our vessel is in dock water of 1.012, we're at a draft of 5.5. So if we go in at 5.5, we can see that if the vessel was in freshwater, our displacement would be 10,908 tonnes. If the vessel was in salt water at that draft of 5.5, our displacement must be 11,180 tonnes. So you must understand this principle of how you get these two different values of displacement, and it's all about the density of the water, because of course the draft isn't changing. Okay? Now if the draft doesn't change, the underwater volume doesn't change. So our displacement must fall between these two values. And we know that weight is volume times density. Freshwater values are underwater volume values. So in this instance, we would simply get the freshwater value, the underwater volume, 10,908, and multiply it by the density, 1.012. So our displacement must be 10,908 multiplied by 1.012, which is our given density of the dock water. Therefore, in port at the moment, at that draft of 5.5, we know our displacement is 11,039 tonnes, which falls between these two values here, 10,908 and 11,180. Okay? And that's how we work out that value there. Now, also, if you knew your weight was 11,039 tonnes, your displacement, and you were in dock water density 1.012, how would you find your draft? Well, we got the same values here, so to work out our underwater volume, it would simply be our displacement divided by our density, and that will give us our underwater volume, which is going to be 10,908, and we would simply go in the value here and look up on the freshwater 10,908, and we find our draft was 5.5. So you can do it both ways round. In this instance, we were told our density and we were told our draft. We simply went in at 5.5, got the freshwater value. Always remember, just get the freshwater value and multiply it by the density. if we'd been given our displacement and we knew our density, we'd divide the displacement by our density, and that must give us our underwater volume. You'd go back in the tables with the underwater volume in the freshwater values, and that would give you your draft.